will solve a problem, search a 2D matrix, that is Leetcode problem number 74, and the complexity of the problem is medium. Okay, so what are the description? Write an efficient algorithm that searches for a target in a name into an integer matrix. The matrix has the following properties: integer in each row are sorted from left to right. Okay, and the first integer of each row is greater than the last integer of previous row. Okay, so from this description, what thing we can understood that the row is sorted from the 0th element to the last element in ascending order. Okay, and the first integer of each row is greater than the last integer of the previous row. Okay, so it is sorted in the column wise as well. Okay, so we need to find an element in this row wise and column wise sorted matrix, 2D matrix. Okay, so in normal search, what you will do, that you will search, do for loop, one from I to n, another from j to m, and find out the element. But the time complexity on that solution will be O n into m. Okay, but we need an efficient algorithm. Here we will solve this problem in O n plus m, not n into m. So with that we can reduce the time complexity of the problem. So how will we do that? Your approach will be, we will start the search from this element, that the first row but last column element. Okay, then we will start our search. Now if our target is greater than this element, okay, so we'll go to the next row, because all the elements will be smaller than this element here. Okay, so we will go to the next row. Now in the next row, if we found that our element is greater than this element as well, it will go to the next row. Okay, because we know that the largest element will be present for any row in its last column, correct? So now if that element is smaller than that last element of a row, okay, means if I here like this example, it is 3. So 3 is given, so first start from the 7. So we'll check that is 3 less than 7. Yes, so we'll go in this direction. 5. Is 3 less than 5? Yes, we'll get that 3 here. If it is 11, so what will be the our search? Here we will start from 7. As it is 11, we will go to this side. Okay, because 11 is greater than 7, we know. So 7, move to this direction. 20. So 11 is less than 20. We will go this direction. 16. Then again we will check that okay, 11 is less than 16 also. Then we come to this house, means this row and column. Okay, so what is the worst case time complexity? See, if my element is present at the last corner, okay, so in that, if we go for that 2 for loop approach, it would be cover 1, 2, this one, this way, and this way, right? So n into m. But here it will be like we will start from here and then we will increase in this direction. It will be linear, it will be not exponential in increase. Or let's say it is present in 23 here. So worst case it will be increased to this, it will be from here to here, means how much? M, and here to here n. So worst case it will be n plus m. Okay, so here the complexity has been reduced. So now let's see the constraints. Constant is 1. That means we can assume that the matrix will not be empty. We will always get some value in the matrix. Okay, so first we'll, from the matrix value, we will find out the n and m. Let n will be the row, so matrix dot count, cool, and m, that column, number of columns, we will get it from matrix 0 dot count. Now we'll take to variable I, which will start from 0, and variable j, that will start from m minus 1, that first row last column. Okay, now I will run a while loop, that until my I is less than n and j is greater than equal to 0. Okay, we'll iterate that. Means in that way we can still iterate to this point. Okay, so if I is less than n, j is greater than equal to 0, we'll start our search. So let's say if my present at the beginning itself, so matrix I comma j, I j, it will be it is equal to the target. We will just return true. Okay, if I found this in the I comma j position. Now let's say my element is greater than that I comma j. If matrix I comma j is less than the target, okay, then what we will do, that okay, my matrix I comma j is greater than, so we will go to the next, our next row. Okay, I plus equal to 1, because our search is started from the right side of the column. Okay, so that means we are for any column we are covering from here, this side. Okay, so that means already these areas are already covered, so you need to go to the next row. Now in the next row, if my target, it will go to the next row. Now let's say my target is less than matrix I comma j. That means obviously it will not go to the next row, it will go to the next column. So we will reduce the j value, j minus equal to 1. Okay, so in that way we can search it, and if it is not present, then here you will not get this with the search area, and it will be return false, because in that case let's say the value is kind of 70. Okay, so if we start from 7, it will go to 20, 60, and it will be then here. So my I will be increases, so it will be came out from this loop and it will be return false. Or let's say it is somehow 22. Okay, so I will increase that 7, it will be 20, 22, it will be 60, 60, it will be reduced 34, 30, 23 out. So it will not present here, so it will be return false. Now run. Yeah, it's accepted, and here the time complexity is O(n plus m), and here we are not using any extra space. Okay, so page complexity is O1, and if I submit this, yeah, it's accepted. Okay, so guys, if you like this video, please hit my like button, and for getting this kind of videos in future, please subscribe to my channel, and to get the notifications of newly updated new videos, please press the bell icon. Thank you. Thanks for watching this